Hi, good morning, everyone. I'm quite nervous. Okay, so let's begin. So for the first one, for the step one, we have to specify the model based on equation 5.1. So based on the given seven independent variable, and then this is the equation. Life expect, which is the y variable, is equal to beta 0 or intercept plus the seven other independent variables. As mentioned in the screen, there's a lot. So second step is that we hypothesize the signs of the coefficient. So based on our class discussion, the median household income should be positive. So based on I just read this. The median household income is the number that falls in the middle of all incomes and better reflects the income status of most households in a geographic area. So it may determine the spending capability of a family. So not just for
Okay, let's all skip here.
okay.
Then go ahead directly to the hypothesis testing.
All right. So for the steps 5 and 6, we combined the T statistics and p-value approach to do the hypothesis testing for all variables except for metro variable, which we have to do two-way testing. So for median household income, our the null hypothesis is that beta 1 is less than or equal to 0, and then the alternative hypothesis is that beta 1 is greater than 0. So the alpha level of significance is 5%. And then computing for the critical value, we refer to the table, and since there is no value for 3 degrees of freedom, we just use 40, and the value that we got is 1.684.
Well, so your conclusion is do not reject.
Yes, do not reject because
And what does this mean?
we do not reject the null hypothesis because there is enough evidence to infer our alternative hypothesis, because when we check the critical value approach, the T statistic from the
Enough
regression,
or not enough?
there is not enough. Sorry, that's
Not enough.
Yeah,
right?
that's
Okay,
just
okay.
typo.
Okay, all right.
Because the value a negative for 0.488 falls in the non-rejection region, and also if we check the p-value approach, the p-value, which is 0.628 divided by 2, is equal to 0.314, is greater than the 5% alpha level of significance. That's why we do not reject. And then similar to the first one, we also do not reject the null hypothesis for the uninsured, because but for this one, we use the negative value for the critical value, because we are looking into the left tail probability, or the left hand side. So that's, and then for the regression.
This is positive. This is positive. Okay, so here is positive, and this is greater than this one.
Yes. So it does not fall in the rejection region.
Okay.
For the smoke variable, we have the opposite hypothesis. So this one, the null hypothesis is that beta 3 is greater than or equal to 0.
Okay.
Alternative hypothesis is that beta 3 is less than 0. So again, since we're looking into a negative relationship, we look into the left tail probability. That's why we use the negative 1.684 and compare it to the t-test value. Professor, do I have to go one by one to this? Because for the remaining variables, they are just basically the same. You all get the reject null hypothesis, and the expectation is that it would have like negative relationship with the life expectancy.
Mm-hmm. Okay.
And now let's go to the exciting part for the metro variable. So this one, we did the two-way testing, or
And how
two-sided
about the
test.
chin birth? Is this?
Yeah,
chin
teen birth,
is
we are
the-
expecting negative relationship.
Yeah. Okay. Sure. Sure.
We
sure.
also reject this.
Then Gunlow
Ganlo, we reject it.
is positive, right?
Yes, it's
Okay.
positive, 16.84. But the value that we got also falls on the rejection region. And also the p-value is greater than 5% level of
Smaller
significance.
than.
Yeah.
Smaller than
Yeah.
5%.
Yes.
Okay.
So for the metro
Yeah. Okay. Here, let's see this one.
for the metro variable,
There's two-sided test.
it's a two-sided test. So the null hypothesis is that beta 7 is equal to 0, and our alternative hypothesis is that beta 7 is not equal to 0. We set the alpha level of significance at 5%, and then we look into the table. But since this is a two-sided test, our critical value changes from 1.684 to positive and negative 2.021.
Mhm.
And then comparing the value that we got
Yeah. Okay.
for the t-test, it still falls on the rejection region.
Yeah.
And then for the p-value approach, we don't need to divide it by 2. So the value that we got from the regression is 0.0227, still less than 5% level.
Let me see. This one is divided by 2 or not?
It's not divided by 2
You
because
should divide it by. Oh, this two-sided
This is
test.
two-sided
Just
test, so
use
we
the
don't have to
original
divide.
p-value. Sure.
yes. Then additional step for this one is that we do confidence interval approach, wherein
Okay,
the
you-
formula is
Just using the formulas.
Yes.
Okay.
change in beta plus or minus critical value times the standard error of the beta. So from the regression result, we all know that the beta is negative 0.16. Critical value that we used is the 2.2021. And then the
Okay.
standard error is 0.007. If you round it off, and then we get this value, both negative. It does not include 0, that's why we reject the
Yeah, sure.
null hypothesis.
Sure. Then overall test.
For the overall F-test, we run it using the Excel.
Well, you can just see the output.
Yes,
Okay.
but earlier you mentioned that you can
Yeah.
just refer to the regression.
Yeah. And you can use this one to do the confidence interval approach too.
Yes.
Okay, so that's. Did you have confidence interval? Let me see. Oh, no. I mean the one. What's the Excel output?
No, just
Yes, you do have this one. Okay, here. So let's see the metro.
yeah, here, the 0.0.
So there's two parts, right?
Yes.
But those numbers different from. Is these two numbers the same as yours?
0.227, I think that is.
Let me see your confidence interval approach here. This
Hold
one.
on. 0.
How come this
157
number
of
is
50.
different? Where did you get this one?
That is from the regression.
Let me see. Let me see. It's this one, right? Okay, then
Yeah.
let me see your Excel. The Excel is also this one, right?
Yes.
Then, so this one should be these two numbers.
Okay.
Some calculation is wrong. So is this correct? It's 0.025. Let's see. 0.025. Yeah, that's right. then
And then that is
what is this?
the beta.
Huh?
Because we have to multiply the standard
No,
error.
no. Standard error of the beta instead of beta. This is beta.
Oh, okay.
This is standard error of the beta. So it
Hold
should
on.
be like this one. It's this one. Everybody see this one? Using this number instead of this number. This is the beta.
Oh,
This
yeah.
is the standard error of the beta.
Yes.
So you have to use these numbers.
Okay, so we
Okay.
don't have to multiply it.
You know, if you don't understand it, you know, now you have to,
Yeah.
you know, revise your mind.
Yeah, that's why it's
Okay, so using this one, then
So
okay,
we
go
we
on.
don't have to like multiply it anymore. We just put in the standard error of the beta, which is 0.07. That's why it has.
Yeah,
Sorry
sure,
for
sure.
that.
So this one.
Yeah, just
Eh?
that.
So just using this one times this
Yeah.
one without this.
Yeah, yeah.
Okay,
That is not
without
enough.
this.
Yeah.
Okay,
Sorry.
then you will come up to
The
the
same.
numbers like
This one.
this range.
All right.
Okay, then this is. I'm sorry. This range.
The upper and the lower.
Okay.
All right.
Then all positive. Zero does not contain included in this interval.
Yes.
Okay. Very good. Very good. You know, just this numbers calculation.
Math
wrong.
problems, I'm
That's
sorry for
okay.
that.
The concept is very important. Okay.
So for the overall F test, we check for the F critical value. So
Okay.
based on this, we know that the numerator is 7 and the denominator is 43. We look into the table. So the value that we got is 2.25. And then we compare it with the F statistic of 37.808. So comparing the two, that 37.808 falls under rejection region.
Yeah. Okay.
So we reject the model.
Okay.
And then for the conclusion part, we have my answer is no. Holding all other variables as constant, passing a gun law to protect the children increases life expectancy by 0.48 year, or that is around 175 days. On the other hand, holding all variables as constant, for every 1% increase in the percentage of smoking adults, there is an increase in life expectancy of 0.22 year, or that is 80 days. Therefore, if you reduce the smoking percentage by 3%, there's an increase in life expectancy by 0.66 year, or 241 days. Apparently, the difference in the absolute value between the two, passing the gun law and 3% decrease in smoking, is not significantly high. And moreover, the two cannot be directly compared because gun law is a dummy variable while the other one is quantitative variable.
Okay, very
you.
good, very good. Okay, thank you very much. Who wants to be the next? Okay, Sylvie. Let me see. Here. You can make it larger. Make it larger.
Okay, good morning, Prof. Ko and everyone. Today I will presentation from our discussion. For the step 1 is specify the model. So this is the
Well,
equation.
just go ahead to hypothesis testing.
Okay. So for
I'll see the rest of them. Okay.
Oh, okay. So for the step 5 and 6, we combine tool for the hypothesis testing, and the met income we have the conclusion that do not reject the null hypothesis. There is not enough evidence to infer the alternative hypothesis. For the uninsured, the conclusion is same from the met income, so do not reject the null hypothesis. For the smoke, the conclusion is reject null hypothesis. There is not enough evidence in for the alternative hypothesis. is same with obesity and teen birth,
Okay.
gun law. Yes. And this is for the metro. Our conclusion is same. Reject the null hypothesis. So the reject null hypothesis are smoke, obesity, teen birth, gun law, and metro.
Okay.
This is for the step 7 for the overall F test. The conclusion is reject null hypothesis. There's not enough evidence to infer that at least one beta j not equal 0.
What is this the probability? Overall
this
F
is
test.
The p value.
Where is it? The p-value.
This is
The p-value is here. It's almost
Oh.
0 instead of 0.22 something.
oh okay.
I think
Maybe
you
I-
copy this one. You copy this one.
Yes, maybe I
Just
wrong
typo.
the wrong to
Okay.
Sorry. Yes.
My
It must.
my eyesight is not very good, but I can see the I can see the wrong one.
Okay. Yes, it's maybe. It must be 0.
Yeah, I know. Okay, I know you understand. Okay, number 8.
Okay, for the step 8, our conclusion and calculating from the equation the impact of reducing smoking by 3 percentage point, the life expectancy will increase by 0.22199 multiplied 3 equal to 0.66 years. Meanwhile, passing a gun law to protect children will not give a bigger impact on life expectancy than reducing smoking by 3%, which increases only by 0.484511 years. Yes, yet those variables cannot be compared directly as the type of data. For gun law variable is categorical data, and while smoke variable is numerical data.
Okay.
Okay.
Okay, thank you very much.
Okay, thank you.
Who will be the next? Sachin is not here today, right? Sachin. Who won't be the next? Who wanted to be the next? Okay. Rachel. Make it larger. Okay.
Okay, good afternoon, everyone. I want to present our discussion, and let's skip this one. Ah, okay. Okay, this is the estimation, and for the step 5 and 6, we combine it together for all the variables. And for the mating, we state that it has a positive relationship, and blah 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 blah. For the conclusion is do not reject the null hypothesis because there is not enough evidence to infer beta 1 greater than 0. And for the uninsured, we state that it has a negative relationship. And the result is do not reject the null hypothesis because there is not enough evidence to infer beta 2 less than 0. And for smoke, we state that it has a negative relationship. And the result is rejected the null hypothesis because there is enough evidence to infer that beta 3 is less than 0. And for the obesity, we instead that it has a negative relationship. The conclusion is rejected the null hypothesis because there is enough evidence to infer beta 4 is less than 0. For teen birth, we instead that it has a negative relationship with the life expectancy, and the result is the result is rejected the null hypothesis because there is enough evidence to infer beta 5 is less than 0. For the Gunn law, which is the dummy variable, I'm not really sure. The null hypothesis will be equal to 0 and the alternative.
What's Gunn law?
No. No.
Huh? Excuse me?
No, actually, I was actually a little bit confused because the
Yeah, no problem. You can do the two-sided test.
but just do it one-sided test.
So you're working with one-sided,
Yes.
but you stated the
Yes.
two-sided in alternative hypothesis.
I guess I was doing
Okay,
wrong.
okay, okay. So you wanted to do the one-sided test.
Yeah, but I write it
Okay.
like this. I guess this is wrong.
Okay, okay.
Okay.
So this is positive, right?
Yeah, it has a positive relationship and rejected
Okay.
the null hypothesis, and this one is two-tailed test metro. For the null hypothesis is beta 7 equal to 0, and the alternative hypothesis is beta 7 unequal to 0. Okay. This is the confidence interval approach.
Confidence interval approach.
Yes.
So this is not right. Is this right? No, this is not right.
Yeah, I already double check it with the
Excel.
yeah. Wait,
You double check
it's
it?
here. Yeah,
Where?
but I already called it
Yeah.
several times, but it turns out a different number. But I didn't know why. Maybe because of the
Okay.
decimal number or something.
Yeah,
that
understand it.
Has different. Yes. Okay. And
Number 8. Number which the last one. Step 8.
step 8.
Oh, step
this-
step 7. I'm sorry.
This is the overall F test. This is the F and the critical value approach,
Mm-hmm.
and the p-value approach. I get this number from the Excel
Yeah. Okay.
table, and for the conclusion is rejected the null hypothesis because there is enough evidence to infer that at least one of the B unequal to 0.
Beta.
Yeah. And
Okay.
Okay, beta.
All right.
And for the conclusion, the variables are not comparable, no matter how bigger or smaller the coefficient is. For instance, the Gunn law variables has the largest coefficients in that model. Meanwhile, the smoke variables has the lowest coefficients, but that doesn't mean that the Gunn law has the biggest impact on the life expectancy, even though reducing smoking by 3 percentage point. If we want to reducing smoke by 3% means that 0.66 increasing the life expectancy. But yeah, the variables cannot be compared, and the Gunn law is dummy variable, which is categorical, and the other one is quantitative variable or numerical. Okay, that's all. Thank you.
Okay, thank you. Okay, so Pacha will be the next. Okay, sure.
For step 5 and 6. Okay. Okay. For step 5 and 6, medium. For p-value is the p-value approach is 0.3 0.314 is greater than 0.05. So we could say that we not reject new hypothesis for the result. We not reject. Yeah. For the next one, the result is the same with the medium. We not reject the new hypothesis. For smoke, the p-value is less than 0.05, so we could say that we reject the new hypothesis. For obesity, p-value is less than, also less than the 0.05, so we reject the new hypothesis. This one. And teen birth also reject the new hypothesis. For the gun law, also reject the. And the last is two-side test. For the result, reject the. For confidence interval approach, we got one is the 0.0157. Is that right? It's not. It's wrong.
How come you all get this number like this? Again, excuse me. Go up.
Go up.
Go down,
Go
please.
down.
Sorry.
This one.
Look at the expression. This is beta hat plus and minus critical value of the t times standard error of the beta. Okay? So you don't have this one. Okay? And again, I say that you can double check it with Excel output, right?
Okay.
Okay?
Move to step 7.
Would you please make it larger?
Larger. Okay.
Yeah, okay.
Okay. For F test, F test is 37.808.
Mm-hmm.
And we reject new hypothesis.
Okay.
Okay. For the last step, uh, although the Galois coefficient is greater than the smoking variable, reducing smoking by 3 percentage points reduce the negative impact. When smoking is reduced by 3 percentage points, average life expectancy increased by 0.66. But however, implementing Galois will only increase life expectancy by 0.484.
So what is it?
But another reason is that Galois is a dummy variable.
So do they comparable?
Yeah.
Huh? Do they comparable?
No.
Yes or no?
No.
Why?
I don't know how compare.
Why it is not comparable?
It's
The statement you just show here seems that it can be compared,
it can be compared.
right? The statement, like you know, by reading your writing,
It
your conclusion that they are comparable, right?
cannot. Not.
Is
It's not.
that what you want to say?
Yes. It's not.
Yeah. Comparable or not comparable?
Not comparable.
Why?
Dummy. Because
But you didn't mention it here. You didn't say there's a dummy.
To write the.
Yeah. Okay.
Thank you.
Understand it. Okay. All right. Who want to be the next? All right. You know how to download it? Find your name. Jun Kai. Here. Yeah. Then, okay. No. Yeah. Then lower. This one.
Hello everyone. So I'm going to present our discussion. So let's go to, that's my estimation. So I combine step 5 and step 6 together. For the medium income, we expect that that's positive relationship. And then we do not reject the hypothesis here. For the uninsured, we expect that that's negative relationships. And that's also, we do not reject the hypothesis. Yeah, for the p-value approach, same. We do not reject the hypothesis. For smoke, we expected that that's negative relationships. Then, as you can see, that's lower than our T.
What is this expression?
Yeah, that's my mistake. I hope you agree. Yes.
You have to be very careful to what you write. Okay, I understand that this is since alpha
Yeah.
0.05, therefore the critical value is this,
Yes.
but they are not equal.
Yes, that's.
Okay.
I think okay. For the opacity. Oh, I didn't write it down this time, I think. Yes.
Good.
I think I forgot to erase that. After that, I realized that mistake. But
Yeah,
I
okay,
forgot, yeah.
sure. Understand it.
And then yeah, for what this is opposite, we ignore. I don't know. We reject the hypothesis. And team burst, we expected the negative relationships. And then yes, we reject the hypothesis as well. And then this is for the count low. Yes, here rejected the hypothesis. For the p-bar approach, also reject the hypothesis. And then for the metro, we need to do it both sides test. And then I think I just found my mistakes here. For this, I simply using like the take a look lower, only lower side. But I need to use 0.025 instead of 0.05 and then take a look at both sides.
Yeah, okay.
But
So
yeah.
isn't it good to do the presentation and also listen to other students' presentation and find out what's your mistake? I think this is a very good way to learn it. Okay, so I hope everybody, really learning from this process. I'm not wasting your time. Show your work, then say something about it. I think it is very, very, very good learning process. All right.
But I think according to my p-bar approach, yeah, we reject the hypothesis for metro. Yes. And then, yeah, here is confidence interval approach. I use this formula, and then beta hat is minus 0.016 and plus minus t confidence. T.
This critical value
Critical
is
value,
also
yes.
wrong.
T.
This two-sided critical
Oh,
value.
yes.
Okay? Although, the numbers, the result is correct, but the number is wrong.
Yes.
Okay.
But I think the relationship will be kind of different number, but we can
Yeah.
reject the hypothesis.
Okay.
And step 7, that's my here. I can like that, and then yes. So we take a look. The numerator degrees of freedom equal to 7, and then for the denominator degrees of freedom equal to 43, and then I actually simply take a look 7 and 40, and then I got 2.25. And here the rejection rule. So if f value is greater than 2.25, then we can reject.
What is your F value?
F value is
It's here.
here.
Okay. Okay, C, a little bit upper. Okay.
Here? Or
Okay, what is this? Usually, if we write down like this one, this is F statistic.
okay.
This one is critical value. You see the notation here. This one, unless you're saying this is the critical value from alpha level. If you just write down this one, it's F statistics. So in this example, it should be something like 37 something instead of this number. And this one is this number. Okay? The notation is important. When you write on your report, then you realize how important those notations, because all this follow your concept. And this is what you have to do when you work on your thesis, right? Everybody have to write on your thesis, right? Okay.
Yes, let's move to the last part.
Yeah, okay.
My answer is no. It's because smoke and gun load are measured using entirely different unit. Especially the
Yes.
gun load measure use a dummy variable. It's yes or no. Then we cannot compare two things. Yes.
Yes, I think this idea follows from the very the first chapter up to now. Therefore, the measurement units and the type of variables, the coefficients, may or may not be comparable. Okay? All right. Thank you very much. So, who's next? Jackie? Okay.
I'm Jackie, and now I'm going to present our first assignment. And step 5 and step 6 hypothesis testing. So the first one is smoke. We hypothesize the variable of smoke smaller than 0, and we choose.
How come you jump so fast to the smoke? I think we started from median income.
Oh, I did not write it in the order that the textbook
Oh,
shows.
okay,
Yeah,
okay,
yeah.
okay, okay.
Yeah. So the smoke, we hypothesize it is smaller than 0.
Let me see your output.
This.
Well, usually if the output like this one, okay, usually, from our model expression, this is the beta 0, okay? Then this is beta 1, beta 2, beta 3. Those beta, the order of the beta is corresponding to those variables. Okay, so if you're saying smoke, this one is beta 3, and you started from beta 1. Is this what you do on the report?
Yeah.
Okay, let me see. Then you started from the
I'll study from the
beta 1 first.
Okay.
And this is really follow the order from our textbook.
Yes.
Yeah, okay, so start from beta 1.
Okay. Beta 1 is the median income. Step 1, we hypothesize the beta should greater than 0. And step 2, we choose the 5% level of significance. So the critical value will be 1.684. And step 4, the rejection rule for the critical value test is that if the t statistics is smaller than the critical value, we reject the null hypothesis. And yeah.
What is this?
This is the t statistics.
Negative 4A7, right? And what
Yeah.
is this?
Critical value.
And what is your critical value?
Is according to the table,
Is
5% levels.
is what? It's this number, right?
Yeah.
Okay, then go on.
It's
How come
negative.
this become negative?
I think it is because we have the negative list 1.
Wrong.
No?
The critical value always follow the sign of your alternative hypothesis. Right? What is our alternative hypothesis? It's
Is-
positive.
Oh,
Therefore, the critical value should be positive. So here is correct. Okay? So now, you need to compare this one with positive critical value. This is very important. You know, I like to show later on, all of you do the presentations. Then I will say something about this one. Okay? This, you should be always compare the direction corresponding to the alternative hypothesis. So alternative hypothesis is greater than 0. This should be positive. Instead of whether this is positive or negative. You see what I'm saying? This is very important concept. Okay, do not just see this one and turn out this critical value and you change the critical value. As long as the critical value is set up, then you have to divide it, rejection region and non-rejection region. Now we are telling the critical value is positive 1.684. Now it turned out to be negative. So this is wrong, okay?
so I should compare it with the positive one.
Yes.
So,
So it is smaller than, right?
uh-huh.
If you compare with the negative, then this one should be greater than this. You see the points?
So it is this one should be greater than the critical value, then we reject.
No, less than positive.
Oh, less than positive.
You follow me?
Not really.
Not really. The critical value is positive.
Yeah.
So you have to compare with the positive.
Oh, with the positive. Oh, so
So,
this,
so negative 0.487
yeah.
is
Po-
less than
Yes, it's less than
positive 1.684. So falls in the non-rejection region.
Oh. May I draw the diagram?
Yeah, sure. Go on. Very good. Draw the diagram. What is a critical value? It's positive.
It's positive.
Yes. Positive 1.684.
So
Then
the rejection area is in this.
Yeah. now you are in negative
yeah.
0.4.
Oh,
so
so-
it falls on the non-rejection region.
Ah,
All right?
yeah.
Good.
Okay.
Now you get it.
Yeah. And for the p-value, the role of the rejection is if the p-value is smaller than 0.05, and we reject the null hypothesis. So I type it wrong here. So because the t statistics, it is smaller than the critical value, and so it should be that we should reject the null hypothesis.
Do not reject.
Oh, do not.
Falls on the non-rejection region.
Yeah. Do not reject the null
Okay.
hypothesis. And the p-value is greater than the
Great,
0.05. Yeah, so it means we have enough evidence to infer the alternative hypothesis.
Okay.
Okay, the second one is uninsured. Okay, uninsured. We hypothesize it is smaller than 0, and the critical value is the same.
No.
It's negative. Yeah, it
Yeah,
should be
it's
negative.
negative.
Yeah. So the rejection rule is if the t statistics is smaller than the critical value, we reject the null hypothesis. And the p-value approach, if the
How come this one is 1.246 is greater than 1.684? What does that mean?
yeah, I think I misunderstand it before, but now I think I got it.
Okay,
Yeah.
okay.
So it should be 1.646 smaller.
Negative.
Negative. Negative. The critical value.
Critical value
should
is
be
negative.
Yeah, if it is smaller than, it is greater than the negative 1.684.
So false on?
So falls on the non-rejection area.
Yes.
Yeah. And the p-value, yeah. So it should be t statistics is 1.246 if it is greater than the negative 1.684, and because of the p-value is greater than the 0.05, we do not reject null hypothesis. Because there is not enough evidence to infer the alternative hypothesis. I think I do it wrong over the variables, yeah. And for the smoke, we hypothesize the variables should smaller than 0, so the critical value should be negative. And if the t statistics is smaller than this critical value, is greater than the critical value, we should not reject we do not reject the null hypothesis. And the p-value approach is if the p-value is smaller than the 0.05, we reject null hypothesis. And so because the t statistics is smaller than the critical value and this is smaller than the 0.05, so it is in the rejection area, so we reject null hypothesis. And there is enough evidence to infer alternative hypothesis. And the obesity. We hypothesize the variables should smaller than 0, so the critical value should be negative 1.684. Yeah, and so if the t statistics is smaller than the critical value, we reject the null hypothesis. And if this is smaller than the 0.05, we reject null hypothesis. Yeah, and because there's a typo here. Because this is smaller than the critical value, and this is also smaller than the critical than the 0.05. So we reject null hypothesis because and there is enough evidence to infer the alternative hypothesis.
Okay.
Yeah.
Go on to the last one.
Next
Metro.
one.
Metro.
Oh.
The last one. Metro.
Okay. Okay, metro. Because it is two-sided, so we hypothesize that null hypothesis is beta 7 equal to 0, and the alternative is not equal to 0. And due to the two-sided, we according to the table, so the critical value should be positively 2.021 and negative 2.021. And for the critical value, if the t-statistics is smaller than the critical value, we reject the null hypothesis. And if the p-value is smaller than this one, we reject null hypothesis. And as for the confidence intervals, it is according to the formula, and it is the coefficient plus and minus the critical value multiply the standard error of the coefficient, and then we get this range. And if the confidence interval contains the value 0, we do not reject null hypothesis. And if it contains, if it does not contain, we reject it. Yeah. So because the t-statistics is smaller than the critical value, and the p-value is smaller than the 0.05, and also the 0 is not contained in this range, so we reject null hypothesis. And there is enough evidence to infer the alternative hypothesis. So, and the step 7 overall f-test. Step 1, we hypothesize null hypothesis. Beta 1 equal to beta 2 to beta 7 equal to 0. And alternative 1, at least one beta j not equal to 0. And j is from 1 to 7. And the 5% level of significance. So it is 0.05. And so according to the result of the regression, and we got the f value, which is 37 at 0.808. And at the 5% level of significance, we refer to the table in the textbook. The numerator degrees of freedom is equal to 7, and denominator is 43. So we got this value 2.25. So because the f value 2.25 is smaller than this one, so we reject null hypothesis. And there is enough evidence to infer alternative hypothesis. And the last step, by holding the other variables as constant, and when reducing smoke by 3%, then we got this number. And by holding other variables as constant, when passing the gun low, we got this value. Yeah, I don't know whether I'm correct or not. So I think there is not huge differences between these two values. So I don't know whether which one affects the most. And I think it is not comparable, yeah, like the previous group mentions, because the units is different, so we cannot compare these two variables. Yeah.
And here you didn't really mention the measurement units.
Yeah, the measurement unit, yeah.
You didn't mention that. And you didn't mention the dummy variables.
Oh, yeah, the
and
dummy variable.
Numerical there. And from the statement you just wrote it here, it seems that they are comparable.
Yeah.
Yeah,
Yeah,
okay.
yes.
Okay.
My original thought is.
Okay,
yeah.
okay. Okay, thank you very much. Thank you
Thank
very
you.
much. Let's take a little bit break, okay? Then just 5 minutes, okay? Then we will have the last one. Thank you.